Okay, in this video, we're gonna clean up some expressions, algebraic expressions using our law of exponents, or different rules of exponents. If you don't know your different rules of exponents, go back and watch the previous video where we addressed that. And if you do know them, these problems are not going to be too bad. So first thing we're going to do in this number one, the bottom we have some parentheses. We're going to take care of those parentheses. We have powers to powers. So we're going to raise everything to the fourth power on that bottom. So the top's going to stay the same. I'm going to write it over here, 4x squared y to the fifth over. I'm going to raise everything to the fourth power, 2 to the fourth power. And I'm actually going to leave that as 2 to the fourth power. You'll see why in just a second. Powers to power, we multiply the powers. That'll be x to the 12th. And then y to the negative 2, power to power, we multiply, and that gives me y to the negative 8. Now, one thing you can do here, I understand that we can't really reduce this like it is. But anytime you notice that a number like 4, a number 4 is actually the same thing as 2 to the second power. If you change it to an exponent and they have the same basis, you can actually use your rule of exponents there. So to divide, we actually subtract. So let's go through all these, and we're only going to do the things that are alike, such as the 2 with the 2. We have 4 on bottom, 2 on top. Since there's more on bottom, you're going to be left with your answer on bottom. There's 4 on bottom, 2 on top, subtract, you get 2. There's 12 x's on bottom. There's 2 on top. Subtract, you get 10. Since there's more on bottom, put your answer on bottom. Now, here's how I address negative exponents. If I bring negative 8 to the top, it becomes a positive 8. We have 5 there already. A 5 and a positive 8 will give me 13 on top. We're going to clean that up. Now I'm going to change my 2 to the second back to a 4, and we get y to the 13th over 4x to the 10th. Next one, you can do some stuff with your negative exponents if you'd like to. I'm not going to on this one. Raising everything to the second power. 3 times 3 is 9. Now notice I went ahead and multiplied those out. Why did I? Because this over here is a base 2, so it's not going to be the same base. You have a to the negative 1 to the second power, power to power multiply. B to the second is b to the fourth. C to the third to the second, power to power multiply. Over here you have 2. There's no exponent on this, so therefore we have a to the third, b to the negative 1, c to the negative 2. Now, anything can be multiplied. You just multiply the pieces that are alike. 9 times 2 is 18. My a's, if you want to move them and bring them to the bottom and all that, you can. Or, since you're multiplying a's times a's, you're just going to add your exponents. So negative 2 and 3 gives me a to the first. B to the fourth, b to the negative 1, add your exponents. That'd be b to the third. C to the 6th, c to the negative 2 will be c to the 4th. No negative exponents, nothing has to move. Next one. First set of, well, it is parentheses, but first fraction bars. I'm taking care of the things that are alike. 5 and 15 reduces to a 1 and a 3. You can divide it, but you're going to get decimals. So treat it, like I said, treat it like a fraction. Now again, here's that negative exponent rule. X to the negative 2 on top, x to the third on bottom. I can take this negative 2 to the bottom. When you move a negative exponent, it becomes positive. On bottom, you have 3 x's. As you move these other 2 down, now you have 2 more, so you have a total of x to the fifth, or 5 x's on bottom. Let me try to write that better. So 3x to the fifth. Doing the same thing here, bring this negative 1 to the top, it becomes positive 1, you now have 4. We're multiplying that times. All this is being raised to the second power, so I'm going to put 3 to the second, x to the 8th, and y to the 4th. You can put that fraction bar there if you'd like to. Now, everything on top, there's no plus or minuses, so you can cancel all you want to. 2 3's on top, single 3 on bottom. Mark them out, you're left with a single 3 on top. There are 8 x's on top, there's 5 on bottom. Mark them out, you're left with 3 on top. There's 4 y's here, there's 4 more y's here. That's a total of 8 y's. Final answer. Okay, number 4. Now, I did notice something here. The number 4, the number 2, the number 8, all 3 of these are base 2 numbers. So what I'm going to do is I'm going to exchange 4 to the 4 with 2 to the second. Obviously, 2 is 2 to the first, and then 2 to the third is the same thing as 8. So I'm going to trade those out. All this is raised to the third power. So first set of parentheses, you have 2 to the 6th, power to power multiply. A to the 6th, b to the negative 9. Second set of parentheses, you have 2 to the second, a to the negative 2, and b to the 8th. Again, power to power multiply. On bottom, we have 2 to the third, a to the fourth, and b to the negative 1. Now it's just combining all the things that are alike. And here's what I'm going to do. Here's all your 2's. And if you'll just count them, we have a total of 6, 7, 8 on top. There are 3 on bottom. When you subtract, you're going to be left with 5 on top. There's a total of 6 and negative 2 is 4. You have 4 on bottom. When you subtract them, you have none left. On top, you have b to the negative 9 and b to the 8th, which is b to the negative 1. And on bottom, you also have b to the negative 1. You can move them if you want to, but they're going to cancel each other out. Final answer is 2 to the 5th, which is the same thing as 32. Next problem. Again, we have rational exponents here. You work them the same way. Everything's being raised to the third power. Power to power, we multiply. That's going to be x to the 6 over 3, or 2, y to the negative 3 over 2, times, same thing here, x to the negative 4, and y to the negative 3. Then you work it the exact same way. To combine x with the x's, you're going to add the exponents. That's going to give you x to the negative 2. To put your y's with the y's, you're going to add exponents. You might have to come over to the side and say, okay, what's negative 3 over 2 plus negative 3? We'll need a common denominator. That'll be negative 3 over 2 plus negative 6 over 2, which is negative 9 over 2. So there's your exponent there. Notice that both of these are negative, so they'll both need moving. So nothing's left on top. You have an x squared and a y to the 9/2 power on bottom. Final answer. And then the last one. Also got some more rational exponents. You've got the number 4 and 2, which are both base 2 numbers, so you can replace this if you'd like. That's 2 squared. Everything's to the third power. So you have 2 to the 6th, a to the negative 3 over 2. I'm just multiplying, and that'd be b to the 9 over 2. Powers to powers multiply. On bottom, you have 2 to the 2nd, a to the 1st. 1/2 times 2 would be 1, and then b to the negative 2. To divide, you're going to subtract your exponents. 2 to the 6th and 2 to the 2nd. You're left with 4 2's on top. Negative 3/2 and positive 1. So what I'm going to do is I'm going to take my negative 3/2 and I'm going to move them to the bottom. You have 1 on bottom. Now you have 3/2 more on bottom. When you put those exponents together, that's going to give you a to the 5/2 on bottom. Same thing here. I'm going to put this b to the negative 2 on top. You have b to the 9/2 already up there. You're going to multiply it by b to the 2nd. I'm going to go ahead and write that as 4 over 2. I went ahead and found a common denominator. So on top, you have b to the 13/2. And I'd probably go ahead and multiply this out and leave my final answer as 16 b to the 13/2 over a to the 5/2.